Today let's talk about PACS data generation. Data generation refers to how much data is being imported and stored through the acquisition gateway or DICOM server. In simple terms, how big are the file sizes of the studies flowing into PACS? And this is different than the acquisition rate, whereas the acquisition rate is concerned with how many studies are coming out of each modality into PACS, and it's number of studies per modality. Data generation is concerned with the data file size from all the different modalities. It takes some math. To figure out how much data is flowing through your DICOM servers, you need to find out some information from your modalities. 1, you need to know what is the average image size for the modality. 2, what is the average number of images for each study. And 3, how many studies do they perform in their peak hour. Obviously, this information is going to be different at every hospital, and each modality within a department will have a different rate. For example, the ER CT scanner will have a different volume than the radiology department CT scanner. So let's say at HAC General Hospital, the average CR image size is 100 megabytes. The average number of images is 2 per study. At the peak hour, they send 12 studies from the CR unit. So how much data is that unit sending to the DICOM server it connects with? Well, we'll have to do some math. So each image is 100 megabytes, and they do on average 2 per study. That's 200 megabytes. 200 megabytes times 12 studies in their peak hour is 2,400 megabytes, or 2.4 gigabytes. So if there are 4 CR units all sending to the same DICOM server, how much data would it be processing? 2.4 gigabytes times 4 CR units equals 9.6 gigabytes. So the total volume of data being processed by the DICOM server in this example is 9.6 gigabytes. It's important to note that this is an example with simple math because as I'm a simple person, I can only do simple math for instructional purposes only and does not reflect real-world data values at all. When you're designing the inbound image flow, you need to account for the data generation by each modality type. If you have 4 acquisition gateways, and gateways 1, 2, and 3 are processing 10 gigabytes of data at peak flow, and number 4 is processing 24 gigabytes at peak flow, obviously number 4 is going to be slower than the rest. You would want to reallocate modalities with lower data generation to server 4 and move a high data generation modality to one of the other servers. It's tempting in solution design to group modalities together. For example, you might want to run all the mammo units through one DICOM server and all the ultrasound units through a different DICOM server. And while that's very effective for troubleshooting, there's a huge difference in file size. The DICOM server for mammo will run much slower than the one processing ultrasound exams. So, in simple terms, mammo files are some of the biggest we store. Ultrasound are some of the smallest. So if you've got 2 mammo units going through DICOM server 1, they're going to be putting huge files into that server, whereas the 2 ultrasound units going through DICOM server 2, they're producing files of kilobit size. That's not going to be a problem at all. That server is going to handle it no problem. So another reason to move modalities around to different DICOM servers is to balance out the data generation flow, in addition to the acquisition flow that we already talked about. So data takes up space. It's important to remember that all of the data flowing into PACS each day eventually gets stored in the archive. Each and every day the PACS archive grows bigger. Whatever your PACS archive file size is today, it's going to be bigger tomorrow and bigger the day after that. Consequently, it's important to know how much archive storage space you are using up each day so you can accurately forecast when to purchase more data storage. Some PACS have a dashboard to tell you how much storage space you are currently using. By checking the dashboard each day and keeping track of how much more space is used each day, you can begin to predict how much space gets used each week. Then you can use those numbers to calculate predicted usage on a longer scale of, say, a month or a year. If you have an older PACS that doesn't have a dashboard and you don't have IT help or IT skills to check the archive itself, then you have to measure the inbound data generation using the numbers from the DICOM servers, just like the math we just did. How long until the archive is full? If you have 4 DICOM servers and each one is processing 9.6 gigabytes of data each day, all you need to do is multiply the numbers to get the total daily volume. So you have 9.6 gigabytes per day times 4 DICOM servers. That means your PAX has taken in 38.4 gigabytes per day. If you generate 38.4 gigabytes per day and your archive holds 5 terabytes, how long until you fill the archive? So I'm going to pause, I'm going to stop this video here and finish this concept with another video. I'm going to do a part 2, and in part 2 I will answer that question. I'll give you the answer. So you can stop here and work on that and see if you can figure out how long it will take until the archive is full. Again, I have to point out the disclaimer that this is simple math for instructional purposes, does not reflect real-world data values. Nobody has a PAX archive that holds 5 terabytes. PAX archives hold hundreds of terabytes of data. If you had a 5 terabyte PAX archive, you'd have the smallest archive in the world. So, not using real-world data. Go ahead, try to figure it out, and I'll show you the answer in the next video.